Hi everyone, we are researchers from the University of Stuttgart in Germany. We would like to introduce our paper Mouse2Vec, Learning Reusable Semantic Representations of Mouse Behavior. Computational modeling of interactive behavior has emerged as a key component to understand users and interaction goals. Mouse input is particularly promising given that it is readily available on a large number of devices and pervasively used in daily life. Mouse behavior is a spatiotemporal signal that encodes both the continuous on-screen location of the mouse pointer as well as discrete mouse events, such as clicks. Common practice in mouse behavior modeling is to use handcrafted features and supervised training that requires ground truth annotated data collected from a large number of users. However, designing and extracting meaningful features requires expert domain knowledge and is laborious. Supervised classifiers require data collection and annotation, which are costly and time-consuming. To address these challenges, we propose Mouse2Vec, the first self-supervised method to learn semantic representations of mouse behavior. The representations jointly encode the time and frequency domain of cursor locations and click information, and are reusable across users, tasks and datasets. Mouse2Vec employs a transformer-based encoder-decoder architecture, and is pre-trained under two tasks, reconstructing the entire input after dropping some slices, and meanwhile detecting the discrete mouse events. Input to our method is the temporal mouse data that also gets transformed into the frequency domain using a discrete Fourier transform. Then we randomly drop slices from the original input to let the model learns contextual information. In the encoder, we first use one-dimensional CNN to learn local dependencies and get initial embeddings. Subsequently, a CLS token was concatenated to the beginning of each embedding. Projected by a transformer encoder, the embeddings of CLS tokens were averaged to yield the final representation of the input mouse behavior. The rest of the embeddings were concatenated together to finish the pre-training tasks. We pre-trained Mouse2Vec on two large-scale datasets, Buffalo and Emaki. We evaluated Mouse2Vec representations from both a qualitative and quantitative perspective. Qualitative evaluations aim to analyze if representations capture meaningful relationships, such as the similarities and differences between mouse behaviors. So we examined clusters at the group level and nearest neighbors at the instance level. Mouse2Vec representations formed 105 clusters on EOTT dataset. We look into the 9 largest clusters, as they provide insights into the most prevalent behavior. Of each cluster, we visualize the 2 most representative behaviors. Most behavior in A, C, E and F came from artificial tasks. This is because to perform these tasks, participants followed the same routines. B, D, G and H comprised short movements within a small area, often accompanied by clicks, suggesting a meaning of adjusting the cursor to click on a target. This finding is in line with prior research that users tend to behave similarly when interacting with a precise target. It's also interesting to look into small clusters since they represent rare behavior. The 3 smallest clusters either include only one mouse or display redundant movements. To summarize, Mouse2Vec representations generate human-understandable clusters. The clusters can be used to automatically annotate trajectories, saving time for human annotators. Based on the sizes of clusters, UX designers can analyze users' common or rare behaviors to improve the usability of an interface. We then zoom into the instance level to retrieve similar behavior based on the cosine similarity between Mouse2Vec representations. In terms of the shape, location and clicks, the retrieval results are better than using classical mouse representations, and also better than the ablations where we removed either the time, frequency domain, or the discrete events encoded in Mouse2Vec. Since Mouse2Vec can be used to find similar behaviors, we can use it to either provide guidance to users who get stuck in a task according to other users who have similar behavior and completed this task, or for data augmentation, since in HCI, we often face the challenge of having limited labeled data due to the high cost of data collection. We conducted quantitative evaluations of augmenting limited labeled data and using Mouse2Vec as a generic feature extractor to examine the practical usefulness of our representation. We chose 3 sample tasks that are important for personalized and anticipatory interactive systems. We ran experiments on 2 open-source datasets, EOTT and Activity. When doing data augmentation, we randomly retained only 10% of training data to simulate a scenario of data scarcity. For each training sample, we used its 9 nearest neighbors to restore to its original size. This table shows the accuracies achieved with and without data augmentation. Data augmentation consistently improved the accuracy across downstream tasks and datasets. Among all the augmentation methods, using the full version of Mouse2Vec always got the best results. Moreover, we evaluated if Mouse2Vec could be used as a generic mouse feature extractor, like ResNet, as an image feature extractor. In the accuracy table, we showed 2 usages of our model. First, directly applying the pre-trained, frozen model, which allows novice users to quickly and easily use Mouse2Vec for their data and tasks without changing the model. This already outperformed all the other representations. Second, fine-tuning the pre-trained model for each task, which targets at users who have experience in training deep learning models, gained even better performance. To summarize, our Mouse2Vec learns semantic representations of mouse behavior, which are human understandable and reusable across datasets. Mouse2Vec has the potential to be used in many applications, including data augmentation, behavior retrieval, automatic annotation, or as a useful, generic feature extractor. In the future, we would like to extend the usage of Mouse2Vec in multimodal settings, adding other modalities such as keyboard, eye gaze, and user interfaces. Please see our paper for more details. Our code will be available for further research.